So the first one says, which geometric principle is used to justify the construction below? Now, I know we didn't do constructions, but it does help us prove or talk about our different types of parallel line angles, all right? And when you have one on the inside and one on the, one on the inside and one on the outside on the same side of a transversal, you end up with two parallel lines that form corresponding angles, okay? So if you remember, these are an example of corresponding. All right, when we have our transversal and our parallel lines, those are alternate interior. Then we have these, 1, 2. Those are alternate exterior. And just as a reminder, those three are equal, all right? So corresponding angles are equal, alternate interior angles are equal, and alternate exterior angles are equal. And then the other one that we talked about were same side, okay, or consecutive interior. And those add to 180, okay? So three of them are equal, one of them adds to 180. You got to know the difference in the types of angle based on their positioning. So if we look at number 2 here, in the accompanying diagram, parallel lines AB and CD are intersected by EF at G and H respectively. If the measure of angle AGH is 5x and the measure of angle CHG is x plus 12, find the value of x. So we've got both on the inside and both on the same side of the transversal. So these are same side interior angles, okay? Which means they add to 180. 5x plus x plus 12 equals 180. We'll add our like terms. 5x and x is 6x. Plus 12 equals 180. We'll subtract the 12 on both sides. 6x equals 168. Divide both sides by 6. And we end up with x equals, now I'm going to have to throw this in my calculator real quick, and I think actually I got something a little bit on the sloppy side, but let's see. Oh no, never mind. I got 28. Sorry, wasn't doing math while in my head. All right, and you get that x is 28. All right, so same sides, add them together to give you 180. The measure of the angles of the triangle are represented by 3x minus 20, 7x plus 30, and 2x plus 50. So you could draw a triangle here if you'd like. So you have 3x minus 20, you have 7x plus 30, and you have 2x plus 50. All right, so it doesn't matter where each angle goes. Just recognize if you have three angles of a triangle, they have to add to 180. So 3x minus 20 plus 7x plus 30 plus 2x plus 50 equals 180. All right, triangles always get added up to 180. So 3x, 7x, and 2x is 12x. Negative 20 and 30 is 10, and 50 is 60. Subtract the 60 from both sides. 12x equals 120. Divide both sides by 12. And x is 10. Okay, remember, just be careful if the question asks you to plug them in to get the actual angles. Okay. Oh, sorry, actually, I realized, oh no, here, they just ended up out of order. So in the accompanying diagram, ACD is an exterior angle of triangle ABC. If angle B is 40 and angle A is 2x, and angle ACD, the one on the outside, is 3x, what's the value of x? So remember our rule. The two insides, so 40 plus 2x equals the outside. All right, so 40 plus 2x equals 3x. We'll subtract the 2x on both sides, and we actually get our answer right away here. That gives us that x is 40. All right, so whenever you have one angle on the outside, and the two non-adjacent ones on the inside, Then you have your two insides added together to give you the outside. And number 5, triangle ABC has coordinates 2, 0, 1, 7, and 5, 1. On the accompanying set of axes, graph, label, and state the coordinates of triangle A prime, B prime, C prime, the reflection over the y-axis. So reflection over the y-axis, I'll start with B. B goes to, right, you go left 1, so you go left 1 again. So B prime then is negative 1, 7. C is left 1, 2, 3, 4, 5. So we're 1, 2, 3, 4, 5. There's C prime at negative 5, 1. And then A is left 1, 2. So it's left 1, 2 again. A prime. And that gives us negative 2, 0. All right, and then we will connect them to make our triangle. Now, the one thing I always want to point out, okay, when you're talking about reflections, notice from A to B to C, the original one was clockwise. From A prime to B prime to C prime, we are counterclockwise. So when you're looking to identify if a reflection has occurred, always check your orientations. Reflections have the orientation flip. All right, so make sure you check that piece if you're trying to compare two triangles. Given point negative 2, 3, state the coordinates of the image A under the composition T, negative 3, negative 4, composed with a reflection over the x-axis. So remember, when we're composed with that open circle, we always start with what is on the right. Now, if I were you, I would sketch a picture here. So, negative 2, 3 is somewhere around here. We'll call that A. So if we were to reflect over the x-axis, we have to go down 3 and then down 3 again. So there's going to be A prime. And what's going to be the coordinates of that? Well, the x value didn't change, and that positive 3 became a negative 3. All right. So we reflected over the x-axis. Now we're going to go left 3 and down 4. So you could go left 3, down 4. So remember, this is also x minus 3 and y minus 4. Okay. So you could also look at it that way. So if you take negative 2 and you subtract 3, you get negative 5. If you take a negative 3 and you subtract 4, you get negative 7. All right. So for these composition ones, it's usually a good idea to sketch a graph if possible, so that this way you can have the ability to do some of your transformations a little bit more easily. Okay. So which composition? Oh, excuse me. The accompanying diagram shows a right triangle if the triangle is rotated 90 degrees counterclockwise. So that is to the left, counterclockwise. About the origin, what will the image be? So think about it. Every time you rotate, it goes over a quadrant. So if this triangle rotates to the left, it should end up in a standing position. So which of those triangles matches if it were in a standing position in that second quadrant? Would be A. Now C also ends up in the second quadrant, but that's more of a flip. All right, this is more of a reflection, where that triangle that stands up is more of a spin. In number 8, in the accompanying diagram of triangle ABC, DE is parallel to BC. So it says AD is 3, AB is 9, AE is 5, find EC. So remember what we said yesterday. Anytime you have all this information, you want to fill in anything else that you can. So for example here, if 3 is on the top and the whole thing is 9, well, we know the bottom has to be 6, because 3 plus 6 will give us 9. And now we can go with our very simple top left over bottom left equals top right over bottom right. So 3 over 6 equals 5 over x. Cross multiply. 3 over 6, or 3 times x is 3x. 6 times 5 is 30. We'll divide both sides by 3, and we get that x is 10. Okay, so a simple proportion setting up based on what they give us. All right. Parallelogram, angle A is 2x minus 10. Angle B is 5x plus 15. So remember, when they are next to each other, they add to 180, right? If 5x plus 15 was at C, you'd be setting them equal to each other. All right, so remember, next to each other, add to 180, across from each other, equal. So 2x minus 10 plus 5x plus 15 equals 180. 2x and 5x is 7x. Negative 10 and 15 is 5. We will subtract the 5 on both sides. 7x equals 175. Divide both sides by 7, and when we do that, we get that x is 25. All right. So again, because they are next to each other, they add up to 180. If they were across from each other, they would be set equal to each other. And the last one here, number 10. Come on, there we go. In the accompanying diagram of rhombus ABCD, the lengths of the side AB and BC are represented by 3x minus 4 and 2x plus 1. Find the value of x. So remember, in a rhombus, all sides are equal. So we're going to take our rhombus sides, 3x minus 4, and we're going to set it equal to 2x plus 1. So we'll subtract the 2x on both sides. X minus 4 equals 1. We'll add the 4 to both sides, and we get x equals 5. All right. So again, don't forget, if it said what was the value of the side, you just have to plug back in. 2 times 5 is 10, plus 1 is 11. All right, so just be careful if they ask you to plug anything back in. But there's our midterm review for tomorrow.